This segment we're going to wrap up reciprocating engines. Just a few more things I want to say about these. So you might be wondering why the Otto cycle and the diesel cycle are modeled slightly differently. So the Otto cycle, we model the combustion process as a constant volume heat addition process, and the diesel is a constant pressure heat addition process. Well, why constant volume? Why constant pressure? Well, gasoline burns really, really quickly. Diesel burns much, much slower, much more slowly. So with an Otto cycle, because that gasoline burns really, really quickly, how we're modeling it is such that that combustion process would take place almost instantaneously before that piston or before the what's in that piston cylinder is allowed to expand. Of course, that's not the case, and you can't really untangle those two events that cleanly. But that's how we're modeling it. And diesel, since it burns slowly, we allow those two events to sort of bleed into one another. So what you're going to see here, this guy's got diesel on the right and gasoline on the left, and he's going to soak the cardboard, and we're going to see which one burns faster. So let's see. So he's going to light it on fire. Gasoline's on the left, diesel's on the right. And what you're going to see is that the gasoline burns, it lights up really quick. It burns very, very quickly. Diesel burns too, but it doesn't light as quick. However, it does burn a lot more slowly. So the burn, it's longer, I guess essentially is what I'm saying. All right, so what parameters can we use to increase the thermal efficiency of a reciprocating engine, or what parameters can we tweak? The compression ratio is a good one. So if you increase the compression ratio of an Otto cycle, you increase the thermal efficiency. Typically, gasoline engines have a compression ratio of 9.5 to 11.5, give or take. Well, why is it, why not 15 or 20? Well, for a gasoline engine, you are limited by the risk of auto ignition or engine knock. So what's supposed to initiate combustion within an Otto cycle or a spark ignition engine is supposed to be the spark. So you're supposed to compress it. You compress your air and your fuel, and you get it to the flash point or the flash temperature. We talked about that in the diesel cycle video. So you get it to that flash point or above that flash point, and the spark goes off and it initiates the combustion process, and it starts to burn. Well, what can happen is if you compress it too much, you may compress it above the auto ignition temperature, so the temperature at which the fuel spontaneously combusts without any spark, without any other provocation. And so what you'll have are these little pockets of fuel that start to combust, and those waves will run into each other, and it'll cause vibrational damage within your engine. So what you can do is you can add things to your fuel to increase your fuel's ability to resist that phenomena. So this is reflected in the octane rating. So the higher the octane rating, the higher the ability of the fuel to resist auto ignition or engine knock. And they call it engine knock because it manifests as a pinging sound. Sometimes it's audible, sometimes not so much. So the higher that octane rating, the higher the allowed compression ratio. So a high performance car would probably need premium gas. If you drive a car like me, you're probably okay with 87. All right, so let's see. So a diesel cycle follows the same rationale. So the higher the compression ratio, the higher the thermal efficiency. And this figure 9.5 also overlays the trends for an Otto cycle as well. Remember, you're kind of limited to that 9.5 to 11.5, depending on the octane rating of the fuel that you use, but 9.5 to 11.5 range for the compression ratio. And then they have this little up at the top, RC equals 1 for an Otto cycle, so that's the cutoff ratio. Remember the cutoff ratio, it's the ratio of the volume after combustion to the volume before combustion. And in an Otto cycle, we model the combustion process as constant volume, so that ratio would just be 1. All right, well, with a diesel cycle, you are allowed much higher compression ratios because you are not really worried about auto ignition, because that's the thing that's supposed to happen. You're supposed to compress the air to a very high temperature so that when you inject that diesel fuel, it'll be at a temperature that's higher than its auto ignition auto ignition temperature, and it'll spontaneously combust. So, all right. Well, I hope that was helpful. Thank you for watching. The next time that we meet, we'll start talking about the Brayton cycle.